Okay, sorry about our usual disconnection. Let us get back to our discussion. So I am actually browsing our previous video lectures, starting from video 1, looking for the chance to have a practice problem solving. I am looking. You can also help me so that we can, so I think there is no problem solving yet in this part. More on introductory explanation. Okay. So if you have previous practice, please tell me which part it is so that we can go to. But let us start with the video 1, then go on. Let us go on up to the current video, one by one. Let us go on. Let's start with this video. Okay, another example. Consultant's calculation. There is a formula given here. So there is what? Computation of difference in diameter. Difference in diameter of this trunnion is very critical because just like we have explained in this video, if the trunnion is within some allowance, it can easily be rotated. And that is the purpose of this trunnion, to be connected to the other parts, but in a manner that it could easily be rotated. If the trunnion cannot connect to the other parts in such manner, it will only add up to our problem because it cannot rotate. The function of the trunnion is for the other piece to be rotated, and if it's not rotating, then it is a problem. Like that, like this in this video, we have a specific example that because of the different values of diameter as the temperature changes, the temperature affects the diameter. How much? This is the computation. 0.01504 inches. From what? From 80 to 108 degree Fahrenheit change in temperature. Because the temperature changes from 80 to 108 degree Fahrenheit, we have this equivalent change, corresponding change. And it's not hard. It is not hard to think about it. It's not hard to judge it because we already know, we learned from physics that objects as the temperature increase, the object also becomes bigger, no? Okay, so there is a principle in physics. Okay, that is a principle in physics that you should know. In general, they are true. I said in general because there are exemptions. There are exemptions to that rule, which says matter expands when heat is applied. There is an exception. And if you are a very good engineer, you should know what are those exceptions. Okay? So, just food for thought. Okay? If you want to become better engineers than the rest of the engineers, you should know those extra knowledge. Okay? Okay? So more of example computation. We have the formula for this, and the formula is here. Okay, this one, multiply. So the formula actually is from thermodynamics or physics. Some physics teacher will teach what heat. This is heat absorbed by the. This is the formula for heat absorbed by the component. Okay, so because of that heat absorption, we have this kind of changes in the size of the component. Okay, let's just continue. So this is the formula used. Okay. And some engineers do not even think that the A, what is the A? A is a physical characteristic which means coefficient of thermal expansion. This is the coefficient of thermal expansion. Okay. So this alpha. This is alpha. So they think that this is constant. This is constant at a specific temperature. For example, at what? At ambient temperature. That this is constant. But look at our application. The temperature rises from ambient temperature to some other temperature, from 80 degrees Fahrenheit to 108 degree Fahrenheit. So it changes. Look at the characteristic coefficient of thermal expansion. At 0 degree Fahrenheit, this is equal to 6 micro inches per degree Fahrenheit. This is the value of coefficient of thermal expansion. So this is one specific example wherein we have a variable physical characteristic like thermal expansion. As you can see in the figure, it is very nearly straight line, but it's not straight line. Okay, it is very nearly a straight line. Okay. Did anybody practice solving this equation using different amounts here? Okay. Okay. So this is alpha. This is temperature change. Okay. Okay. And this is the original diameter. So let us look. What is the original diameter of this part, of this portion? So let's go back. Let us look for the original diameter and practice this. Okay. Take a screenshot. please take a screenshot of this table. Please take a screenshot of this table. And therefore, I will take a screenshot of this table. Also take a screenshot so that we can go back to this. And then, what is the original diameter of this example? So the original diameter is 12.363. Okay. So let us practice having that example. Okay. Okay, let us share another. Okay, let us share our whiteboard. Whiteboard. Okay. And use your calculator. It's our whiteboard. So our equation is, what is that equation? Change or delta diameter, change in diameter is equal to, what is that? Diameter times alpha times what? Change in temperature or delta T. Right? So this is the formula. Okay. So this formula is just like what? Delta, sobrang laki naman ito. Sobrang laki ng pagkasulat. Pati yung isa na ano. So, delta D is equal to D. Is this correct? Is my formula correct? Delta D is equal to D multiplied by alpha, then delta temperature. Okay. So we have a table which we have a temperature and alpha correspondence, no? So there are several tables there. So for example, let us start from the top of the table. So I will look at the top of the table. I will look for my screenshot. So I am looking, please wait. And we have the what? The value of the diameter to be, okay, we have the first, the temperature is what? Negative 340. Okay. What is the usual ambient temperature in Fahrenheit? So let us compute Fahrenheit. So the usual ambient temperature in the Philippines is what? Is, for example, 80. The problem gives 80. degree Fahrenheit. But I do not think that is exactly the same in the Philippines. What is 80 degree Fahrenheit in degrees Celsius? So if we compute, how to compute this? It is just ratio in proportion, no? It is just ratio in proportion. This is what? 100 or what? 30. Ambient temperature in the Philippines is 30 degrees. 30 degrees Celsius minus 0 degrees Celsius. So, but so erase lahat. No? Let's use this. So how do we do it? F degree Fahrenheit divide by minus 32. So this is to be divided by what? By 180 is equal to, what is the ambient temperature in the Philippines? I think 30. 30 degrees Celsius is the ambient temperature in the Philippines. So this is going to be 30 minus 0 divided by 100. Divide by 100. So if you solve for F, you can solve for F, which is the equivalent Celsius, equivalent degree Fahrenheit of what? Of 30. So what happened? If you use your calculator, please. Use your calculator, 180. So I will show you in the calculator. What is that? 180 times 30 divided by 100. And plus 32, no? So I think plus 32. So 86. So 30 degrees Celsius, which is the ambient temperature in the Philippines, is equal to 86 degree Fahrenheit. So that is how to convert, no? How to convert using your calculator. Okay, so therefore 80 degree Fahrenheit is so less than 30. So for example, let us go back here. You can go back here. That is not 30. For example, let us do 28 or 25. What is the answer? 77. So more than 25. So it is about 28. So 28 is 82. So about 27. So later on, I will show you how to do it very quickly with this calculator. There is a formula inside this calculator. There is a formula that can do it, but I will not teach you anything shortcut without knowing the basic. I am teaching you the basic. So 80, so about 80. So therefore, 27 degrees Celsius is 80 degree Fahrenheit. in their country. So 27 degrees Celsius is okay. So therefore, let us go back to our whiteboard. Okay. Let's go back. Where is our whiteboard? So the answer to this is what? The answer to this is F is equal to 87. So, or 86. No? If we have 30 degrees Celsius. But the problem is saying what? So for this is 4 degrees Celsius, which is equal to 30. So if we are looking at 80.6, no? Or 80. Exactly 80. That is about 26. 26.9. Ayan natin, 26.9. Let us confirm with our calculator. 26.9. 26.9 degrees Celsius is equal to 80.4. So actually, that is already acceptable. $26.8, no? 26.8. So that is the okay. And in our table, we have what? Negative 340. Okay, negative 340. The first in the table corresponds to 2.45. So this is our table. I will put the values in the table. Negative 340 degree Fahrenheit. So this is the degree Fahrenheit. Then we have what? We have the alpha. So for this type of temperature, we have 2.45. 2.45. Okay. And what else? What about negative 300? We have what? 3.07. 0.07. Okay. Another one. For example, 0 at 0. 0 temperature. 0 Fahrenheit. This is 6.0. Okay. And for what? 40. Or for 80. Okay. So 80 degree Fahrenheit. This is equal to how many? 6.47. 6.47. These are some of the values from the table. Now, let us use our given. So our given D Diameter is what? Our given diameter is 12.363. 12.363. Okay. 12.363 is the actual. Maybe the target inches, no? The target diameter would be, for example, 12. 12 inches is the target diameter. Then the engineers made the trunnion. 12 inches is very large. That is 1 foot diameter. 12 inches, 1 foot diameter. Trunnion. So after making the trunnion, we have to measure. After measuring, it is found out that the trunnion made is not equal to 12 inches, but 12.363 inches. It is basing on the actual measurement of diameter. So that is our necessary given. So let us find therefore the delta. Delta D is equal to, of course, diameter times alpha times delta T. Okay. So let us do this using our calculator with this table. No, this table. Let us compute. Let's compute the delta diameter. Delta diameter meaning change in diameter. When the temperature changes, the diameter of the trunnion changes. How much change? So we will compute. We will compute here. Okay. This is our table. And let us compute one by one. So this is the type of practice that I want you to do. Actual practice. Okay. I want you to do the actual problem solving practice. Use your pen, use your paper, use your calculator, anything that would help you. Use it. Actual. Okay. So we have the formula, we have the given. Just what? Substitute. Okay. How to substitute? I will show you. Let us substitute. I will share my calculator. Okay, let us look at the calculator. I will show you in our calculator. Okay, so the first line is what? Diameter, which is equal to 12.363. That is the given diameter times. Let us multiply by the alpha or the thermal coefficient of thermal expansion at the first temperature on the table. That is negative 340. Is that correct? That is negative 340 from the table. So I will look at the table. And that is negative 340. Okay. So of course we have to do this. Multiply. Let us first do the delta T before the alpha. So that is for the alpha. As you can see, that is for the alpha because we need to multiply it by, actually you don't need to put the multiplication if you already use what? parentheses so that you can what? You can minimize time. Okay. So if you already use parentheses, no need to use multiplication symbol. So this is 2.40. Is that correct? 2.45. That is alpha. 2.45 is alpha. Okay. So alpha is 2.45. Because we are looking at negative 340 degrees Fahrenheit. Okay. So 2.45 is the alpha. And our temperature is negative 340. 340. And then subtract it to what? Positive 80. Okay, so positive 80. Okay. So this is our formula. Okay. So if you hit equal sign, okay, look at equal sign. Okay, I will go back and forth with the whiteboard. I will go back and forth with the whiteboard. This is our whiteboard. Okay, so we are just following this formula here. Okay, we're just following the formula here. Okay, with this value of D, so substitute here, and then value of alpha from the table here. Why we use 2.45 and not 3.07? Because our temperature is negative 340. We have to solve this first line first. No? Negative 340, then therefore this is 2.45. That's why we have the calculator here, equation here. Okay, our calculator. Okay, so 12.363 is our denominator. Okay, now we are going to the coefficient of thermal expansion, 2.45, and our delta temperature is negative 340, and our ambient temperature is negative 80, positive 80, but minus negative, minus positive 80, that is minus 80. Okay, positive 80, our ambient temperature. Okay, so this is our calculator, then press equal sign. This is the answer. This is our answer. Okay. So what is the unit of this? The answer is 12,721. Okay. 12,721. Okay. So we need to divide this by 1 million because we have what? Times 10 to the negative 6. Let us divide this by 1 million, and that is the correct answer in inches. Okay. Because our 2.45 times 10 to the negative 6. What is that? Here. The what? The coefficient of thermal expansion is 2.45 times 10 to the negative 6. And times 10 to the negative 6 is actually what? Division by 1 million. Let us divide this by, just divide this by 1 million. Or multiply by, you can just multiply this by 10 raised to the negative 6 power. Negative 6 power. That is correct. Okay? That is how you use your calculator. And then press this one. Okay, let us go back. Let's go back. Let us use parentheses. Parentheses. Okay? Okay. We forgot to use the parentheses. Take note. If you don't have the actual practice, you will not know that the calculator will not give us the result if we do not have parentheses in the what? The 10 to the negative 6. Oh, that is an actual information gained from actual practice. Now, we already know. We will not do it again to our calculator. Always use parentheses if we want to multiply